Yeah, well, so let me ask you then. So the chemistry, are you telling me then that you're looking at your sort of basic chemistry being similar to a lead acid battery, or are you looking at materials that are as inexpensive as lead acid batteries?
Basically it is a lead acid chemistry. But what
Okay.
we're doing is we are enhancing and improvising the performance characteristics of this chemistry by making some modifications to the materials, to the microstructure, the way the battery is made, its design, and how we put it together. So the bulk of the battery cost still relies on the lead chemistry, but we made some changes to the design of the battery and the materials to achieve, for example, we have achieved 4x the power density of a normal lead acid battery
Okay.
without compromising the energy density of the battery and without adding any cost to the base cost structure of lead acid chemistry.
Okay, so what you're looking at then is, I'm gathering from what I've read prior to our talk here, is that you're doing something, your initial focus is for the time being on doing a power battery essentially for microhybrids. Is that correct?
Microhybrids and hybrids.
Okay.
So,
So what's sort of the kilowatt hour range of what you're looking at? I mean, the typical micro hybrid somewhere around 500 watts. The Prius is up around 1.3, 1.4 kilowatts.
so Prius is 1.3 kilowatt hour,
Right,
and that's considered a full hybrid.
right.
So we're looking at anywhere up to 2 kilowatt hours on board a vehicle, and within that 2 kilowatt hours, you cover all microhybrids, all mild hybrids, all full hybrids, all the way from start-stop to, let's say, vehicles like Prius.
Okay, so with that capability, then what you're looking at is I mean, that power, you're going up to that 2 point to give the car what? Improved acceleration and larger regenerative energy capture? Go
You're
ahead.
breaking down.
Yeah, go ahead.
So what we're doing is we're not changing the powertrain architecture.
Right.
That's what the car companies do. What we're doing is we are offering an energy storage system with extremely high power capability at very low cost for the car companies to be able to make those powertrain for hybrid vehicles. Um, what we're doing is we're saying we have a battery which is roughly, less than the cost targets that OEMs have for advanced battery technology for hybrid vehicles. So, say $250 a kilowatt hour. You have 1 kilowatt hour battery on board your vehicle. It's 250 plus some system integration costs associated with that, as opposed to that cost being 4x or 5x
Right.
for other technologies.
Right. So what you're, I guess I'm trying to wrap my head around here. You're not wanting to build a car that's got 12 miles of electric driving range like a plug-in Prius. What you're looking at is something in the neighborhood between a Buick with e-assist that's got a 500 watt battery and up to the conventional sort of Prius with its larger battery. And that those batteries are in there essentially to sort of allow the car maker to downsize the engine and pick up any additional acceleration power from that built-in energy that's in the power battery. Is that right?
So the easiest way to demonstrate my point is you take Prius, for example. It has good fuel economy, it has certain range, it's not a plug-in, it's a hybrid vehicle. All we will do is our solution will cut the size of that battery in less than half, cut the cost of that battery by a factor of 3.
Oh, by a factor
And
of what was it? I'm sorry?
3.
3, okay.
So that's the value proposition.
Right.
So in other words, I'm saying I'll give you the same performance that you're getting from nickel metal hydride, 1/3 the cost and less than half the weight, less than half the size of the battery.
Okay.
Because this technology doesn't require all the sophisticated thermal management system that nickel metal hydride technology needs or lithium-ion battery technology needs, as you have been seeing and reading in the newspapers about a very complex thermal management system for vehicles that use lithium-ion battery technology.
Right, yeah.
So that's one aspect of what we are doing. Now, as I said earlier, that our partner, Townsend Capital, has investments in energy storage and energy efficiency technologies in their portfolio. So they're also, they have a major stake in a partnership with Dow Chemical, a company you know, Dow Chemical.
Right.
So we are also working on methodologies to combine the high energy lithium-ion batteries with our high power EPS battery to provide a complete hybrid battery solution for vehicles that require more than 2 kilowatt hours of energy on board. So now if you move towards the right side of the curve, say plug-in hybrid, PHEV 10, PHEV 20, PHEV 30, 40, or 50, like Chevy Volt, now we can provide a solution which is a combination of high energy lithium-ion batteries and high power EPS battery, reduce the overall size and the cost by a factor of 2.
Okay. So let's take the Volt for example. The Volt's got a 16 kilowatt battery pack in it.
Right.
Using, and that of course is, I'm gathering, they've tweaked that battery to be essentially an energy battery to get that 25 to 50 mile EV range, but there is some power capability obviously there as well for acceleration. So if you're going to take, for example, the Volt battery at 16 kilowatts and you would hybridize it where you would have the energy piece of the battery, which would still maybe be LG Chem, but then there would be your part of the battery. What would that ratio look like in terms of either the size of the pack being reduced or the weight of the pack, that type of thing?
Well, if you use Chevy Volt as an example, that particular battery is not optimized for energy or power. It is optimized for both because it needs both. It needs power and energy.
Yep.
It is when you try to optimize it for energy and power, the cost of the battery goes up. You're using a lot of expensive components like copper and cobalt. Whereas if this battery was to be optimized, you could possibly not have to use all those expensive elements and make the battery somewhat lower cost.
Okay.
Let's say today's lithium-ion batteries are $700 a kilowatt hour. You could optimize the same technology for higher energy at $500 a kilowatt hour.
Okay.
So this, instead of the 16 kilowatt hour battery, which is, I don't know, I'm going to guess is about $12,000 today, you could use a high energy lithium-ion battery only about 11 kilowatt hours and supplement that 11 kilowatt hours with EPS battery, which is about, let's say, 2.5 kilowatt hours.
Okay.
So now you shift the power load to EPS battery and you shift the energy load to lithium-ion battery. So now a combination of these two batteries, first of all, the 16 kilowatt hour battery becomes more like a 13 kilowatt hour battery at a much lower compounded cost, and it doesn't have all the same serious thermal and safety issues that a battery which is optimized for both power and energy.
Right. Now,
So the battery is smaller, the cost is cut in half, and you are maximizing the attributes of lithium as well as EPS battery.
okay.
So that's the way we want to address the plug-in hybrid and EVs. But for everything to the left side of plug-in hybrid, which are hybrid, mild hybrid, micro hybrids, we can address that with just EPS battery.
Right. Okay. So you've been in business now for essentially for a year. Kind of where are you at in your business plan? Have you got some batteries that are you at sort of the test cell stage, or do you have sort of prototypes that you're letting OEMs take a look at? I mean, where are you at this point?
So one thing we don't want to do is what many battery companies end up doing, which is prematurely start talking about their batteries and start putting batteries into the hands of potential customers. So,
right.
And that's just the benefit I have by being in this industry since 1982.
Yeah, forever. Yes, yeah.
So, so the first question is where we are. We started with a basic concept, and we are currently making prototypes for in-house testing. Our next step is to make those prototype batteries for what I call for beta testing with friendly customers, maybe national laboratory or a prospective customer who's willing to test our batteries in their environment for their application. So we hope to be at that stage sometime by middle of next year. We started this program last year, and we are actually a little bit ahead of our schedule, which is very unusual for a startup battery company.
Right.
And we also have gotten a lot of support from the state of Michigan. Late last year in December, the governor of Michigan signed an agreement that gives us a battery credit of about 25% on our investments that we are planning on making in our manufacturing facility here in Michigan. Our plan is to complete the process and product validation by next year and start setting up a manufacturing facility here in Michigan for full-fledged production by the third quarter of 2014.
Okay, so you've got a plan. You're a little bit ahead of schedule on that. Then that's good. What are sort of the obviously apart from the technical issues of taking an idea and actually creating a product out of that, what are the other challenges as a startup? I mean, you've been through this, I guess this rodeo more than once.
Yes.
What are the challenges that you face beyond actually getting the technology to work and finding some partners to try it? What are those things you got to use that are still the hurdles ahead of you?
I think the biggest challenge we have is the time. It takes a long time to get your product tested and validated for automotive application. It's just the cycle is too long. So what we're doing is while we're continuing down that path, we are also designing and building a product for smart grid applications where the validation and the gestation period is not quite as long as it is in the automotive industry, to help start the production process and start getting some revenues early on, rather than have to wait for 4 years before we see our batteries in vehicles. So what are the challenges? I think the challenges are just time is the biggest challenge I have.
Okay.
It takes time to cycle the batteries. It takes time to test the batteries. I think that the market will embrace as soon as we or anybody else can provide a cost-effective solution. There are no cost-effective solutions today that I know of. And I mean, you talk about e-assist micro hybrid like Buick LaCrosse. Um, you know, will we see 500,000 lacrosse vehicles made in 2012 and 13? Not unless the cost of that electrification component is reduced by at least a factor of two.
Okay.
And I don't see how that can be achieved unless you make a fundamental change in the type of chemistry that you are you are using. And that's where our strength is.
Right. Well, let me ask you, since you know, obviously you're going to know a lot about nickel metal hydride. I mean, you helped Stan basically invent the technology. There's been this, story going around basically that nickel metal hydride, it got sold out to Texaco, and then it sort of went nowhere. It wasn't given a fair shake. There's still a role for it to play, that type of thing. Sort of, what's your perspective on the future of nickel metal hydride? Does it still have a role to play?
I think what is important is, can a energy storage system be offered at a cost that doesn't add $6,000 to a vehicle with 40% better fuel economy? I think the number has to be more like 2,000, not 6,000, in order for the economics to make sense. Does nickel metal hydride have a role to play in that? Not unless the cost of the materials go back to where they were in the late 90s. Is it a likely scenario? Not in my opinion. We know how to make nickel metal hydride batteries. I mean the industry knows how to make nickel metal hydride batteries with high yields and very efficient process with high quality. But when we put this battery in EV1, nickel was $4 a kilogram. Today, I think nickel is more like $18 or $19 a kilogram. Is it going to go back to that number? I do not believe so. Same case with copper or with some of the other rare earth materials. And nickel metal hydride was a great technology. I'm very proud of having been associated with that. But it has some limitations. And those are the limitations that have caused the hybrid vehicle industry to kind of be where they are. We made, I think, less than 400,000 hybrid vehicles last year. We should be making 4 million hybrid vehicles or more. But we can only do that if the cost of the electrification part of that vehicle is where it needs to be.
Now, are we going to run into the same problem with lead? If you create this where it becomes now cost effective to build batteries based on your chemistry and things, do we create such demand for lead that it does the same thing?
Well, we have a lot of history in lead. Number one, 95+% of lead acid batteries are recycled and reused. The material is reused, which is not the case with lithium-ion or nickel metal hydride. Now, you can recycle nickel metal hydride battery materials, but recycle it into something else, not into batteries.
Not back to batteries, right.
Whereas lead acid in lead is recycled back into batteries.
Can your battery be recycled then?
Exactly the way the current lead acid batteries are being recycled, the same infrastructure that is in place today. And lead prices haven't changed a whole lot. And you can look at the metal prices. They've been where they are today for the last 15 years, 40 years.
Yeah. There have been a number of companies in the past that have tried to sort of update lead acid battery, the most recent, of course, being, I think, Firefly. There was a company, I can't remember exactly the name, over in the UK that has, tried to do an advanced lead acid battery. Haven't had a lot of success. In fact, Firefly eventually, they were going with a carbon type core to them. What's going to set your battery apart? What's going to make this a success where these other companies just haven't been able to make a go of it?
Well, your question reminds me of back in the mid-80s when we were working on lithium-ion hydride batteries, and we kind of shared this idea that someday lithium-ion hydride battery will be in electric vehicles, and we were told by the so-called experts that as long as you have nickel in your battery, it will be possible to make that battery cost-effective. Because the amount of nickel that you need, and this is back when nickel was $3.50 or $4 a kilogram. So it's not how much nickel you use, it's how effectively you can use nickel. So what we are doing is we are working on the utilization of the material that has not been fully utilized in these chemistries. Our approach to improving performance is very different from some of the names that you mentioned. Our approach is at the very fundamental level in terms of the material science and the internal design of the battery. Something that parts of it has been tried in the past but not really successfully. So we're taking it to the next level, and we've been very, very lucky, very fortunate that we have achieved the results that we set out for ourselves here in the last 1 year. I don't see any challenges beyond what I just mentioned. There are usual challenges. We make sure that we make the product, and I'm sure, in the life of the development program, we have some setbacks and some failures, but analyze it, resolve it. I don't see any fundamental problems that others have experienced, including some of the names that you mentioned.
Okay, good. Well, look, we're running way past what we were going to do here. Thank you. I mean, I would love to take more time, and maybe we can do this as things develop along. So,
no, I'll offer you. If you want to leave Omaha for a couple of days and come to sunny Michigan, come and visit us.
Well, when the cherries are being harvested, how's that?
Yes, see the operations, meet the people. It's all about people. I have a phenomenal group of colleagues and people who are helping me make this happen.
Great. Well, thank you so much.
By the way, I invited Stan to visit us. He was extremely happy with what he saw.
Oh, good. So, by the way, just for everybody, how is Stan doing now?
He's doing very well.
Good.
He has the same vigor and enthusiasm that he did when I first met him in 1981.
Good for him. That's great. A man I greatly admire.
Yes, so do I.
Yeah, good. Subhash, thank you so much.
You're welcome, and stay in touch.
Okay, will do.
All right.
Okay, bye-bye.